right here, out of the sum from 1 to n of a sub k, which is just from a sub 1 to a sub n, then what I'm left with is a sub j plus 1 through a sub n, which is what this guy is. This guy. Oops. Oh, I got to be careful with my equals, don't I? Let's do, because one of you guys is going to get really confused. Let's do this. This implies that the sum as k goes from j plus 1 to n of a sub k is equal to the sum as k goes from 1 to n of a sub k minus the sum, the sum as k goes from 1 to j of a sub k. Okay? Now, the notation looks really hard, and if you show your parents, they're going to be like, wow, you're learning some real mathematics now. You're smart. Awesome. Whatever. I don't care. What you've got to do is you've got to get rid of you've got to get used to the language of math-ese. This is what I'm talking about speaking the language of math. It's not very hard to speak, right? It's just like anything else. If you know what the letters look like, it's pretty easy to speak the language. Unless you're trying to teach a 7-year-old how to read, and then it's a little tricky. Or at least become quite a reader. Whatever. All right, let me give you three quick sums, actually 4 quick sums, and you're going to use the pistols out of these, and then we're done with the section. Okay. All right. We're going to do the sum as k goes from 1 to n, of a constant. I want you to think about this. All right. So remember, this guy right here is simply a sequence. It's a set of numbers whose range, produced by the range of a function. Well, so the range of a function is a constant. If the range of a constant is, or a range of a function is always constant, it's a horizontal line. Really what we're doing, I'm going to go this way. What we're doing is we're taking this function, y equals c, and we're cherry picking all of the integer values. So here's 1, here's 2, here's 3, etc. And we're sticking them in here, right? Right? And they're all, when x is 1, y is c. When x is 2, y is c. When x is 3, y is c. So all this thing's doing is spitting out c when n equals 1, c when n equals 2, c when n equals 3, plus, guess what my last term is? Can you guess? Can you guess? Yeah. C. Well, how many times does it do that? It does it n times. All right, and we end up with n times c. Last I checked, if I take a constant and I add it to itself n times, I get n times c. All right, now, the following 3, then we're done with the section. The following 3 are probably sums that you've seen before. We're going to prove them later on in the chapter, but let's do this guy. All right, so the sum is k goes from 1 to n of k. Well, let's list a few terms. 1 plus 2 plus 3 plus ... plus n. Well, the sum of the positive integers from 1 to n, you may have seen this before, you may not have, is n times n plus 1 divided by 2. Again, we're not going to prove it right now. All right, how about this guy? If I go from k equals 1 to n of k squared. Well, that's 1 squared plus 2 squared plus 3 squared plus ... plus n squared. And this is n times n plus 1 times 2n plus 1 all over 6, which is it's kind of a crazy little equation. But again, don't sweat it. We're just going to have to use it. And we'll use it in class. I'm just giving you the formulas for now. You want to make sure that you write those down, okay? And then last but not least, and then we're all done, is the sum as k goes from 1 to n. That looks like it goes from 4 to, what the heck, to n of k cubed. And all that this guy is 1 cubed plus 2 cubed plus 3 cubed plus ... plus n cubed. And strangely enough, it's n times n plus 1 all over 2 squared. Which is crazy. All right, so that's it. You get yourself enough information to play around with sequences, have a little fun with them. Let me do one quick example, just because I love to annoy you guys. I just love it. So, sorry, that's not very nice. Let's do this as, let's go as k goes from 1 to 10 of 5k plus k squared. Now, notice that 10 is prohibitive enough. Some may say, well, Rupert, I can just do it by hand. I'll just plug 1 in, et cetera, and then I'm all good. Well, 10's pretty dang big, and if I threw 100 in there, then k would be really freaking big, right? It's prohibitive enough to say, you know what, it kind of behooves me to use the formulas and the properties. Well, the first thing I'm going to do is I'm going to use my property because I'm going to split up my sum. I'm going to turn this into the sum as k goes from 1 to 10 of. Now, I could write 5k, but why don't I just throw my 5 out in front, because I can use this property right here, right, which says just pull a constant out. Whoops, where's that property? I wrote it down here somewhere. Where's my property? Oh, here it is. Sorry, looking around. Got too much black ink on this thing. All right, sorry about that. 5 times k plus the sum as k goes from 1 to 10 of k squared. I just use my formulas. This is going to be 5 times, now notice, n equals 10. So if I just use the formulas that I just gave you, this is simply going to be 10 times 11 divided by 2 plus, same thing, n equals 10. So I'm just going to go 10 times 11 times, let's see, what is that, 2 and 21? 21, all divided by 6. Okay, fair enough? Oh, wow, what was I thinking? Let's see. I'm going to cheat a little bit here. I'm going to divide 2 into 10 and I get 5. 5 times 5 is 25. 25 times 11 is what? 275, right? This is 275. There's a trick there. I don't know if you guys have ever seen it, but if I do like 11 times 72, right? All I do is put a 7 here, a 2 here, and the sum of the two numbers here. Now the problem is, if they sum to a number greater than 10, then you have to carry that number over here. It's kind of a trick. So what I did is I divided by 2, gave me 5, 25, so 25 times 11, I go 25 and 11. I just put the 2 and the 5, and then I sum those two, and I get 7. It's probably more information than you needed. Let's see if we can simplify this a little bit. Ooh, and this is where colored pens come in handy. I can turn this guy into 3 times 7, and this guy into 2 times 5, and then that 2 and that 3 go away, and that 6 goes away, right? Ooh, look at that. So I end up with 35 times 11. Does that sound right to you guys? So 35 times 11 is just what? 335 is 385, right? That looks pretty good. And what's that give me? 660? 660. Nobody can double check. You can yell at me 15, 6, 106. Yeah, ooh, yeah. So probably not your first guess if you were doing this thing by hand. Yeah, you'd probably make a mistake too. So wonderful little tools, wonderful little properties. Hope you enjoyed the presentation. I'll see you in class tomorrow. Have a wonderful day.